we got that to turn in. Okay, did you have any questions on it?
I have a question over once you put the marginal utility of the lures over the marginal utility of whatever.
Yeah.
Simplify it all down. Can you get the number out?
Yeah.
For some reason, when I looked at the problem we did the other day in class, I thought that instead of having 2 over 1, I ended up with 1 over 2 to begin with. I just didn't.
Instead of having 2 over 2, or let me.
2 over 1. 2 over 2 was for part B.
Oh, that's part B. You're talking about for
Part A.
part A.
I was 1 over 2.
And so you just flip those around?
Yeah, I guess I didn't. I think the reason I did it is because that's what it looked like we had done on the problem we did in class.
Oh, I wonder if you were possibly matching the letters with the numbers kind of similar rather than just following the condition maybe? Let me pull it up here. Maybe. Ooh. There we go. So you're talking here, right? Part A?
Yeah.
This 2 over 1?
Yeah.
And you got 1 over 2?
Yeah.
I did it the first time too.
And you did that too? What do you think you did?
We did on the problem we did in class. So that's why I had it done.
Did you figure out what you did or not? No? And you too? All right. Well, let's see what you did here. What's the?
Maybe we can get our papers back and she can follow what we did.
Yeah. Here, I'll let you distribute it back. Okay, so on the problem, what was the, refresh my memory, was the 2 and the 1 was the price?
Yeah.
Okay. And guitar picks for 1. So we've got, I think what you're doing is the thing that you guys really have to be careful about that I tried to stress on Monday. I'm not sure this is what you're doing, but let me say this first. So the marginal rate of substitution is, what's the L? Lures, that's right, okay. Know that on my examples here. So the marginal rate of substitution of lures for guitar picks is the marginal utility of lures over the marginal utility of guitar picks. And I'm thinking that you're switching around then once we get to the first order once we get to the setting that equal to the price ratio, which is what they're doing in this step. Is that right? Or was that this problem was worded a little bit differently? Those are the prices?
The price of L is
The price of L. Oh, that's right. This is 2 times.
and you have to do the
Okay. All right, so let me stick with this thought here. So this is equal to the price of lures over the price of guitar picks. So where did you put the 1 over the 2? Or how did you get the 1 over 2? Because you just basically inverted it for some reason.
Yeah.
So did you just flip those around maybe?
I mean, I initially started it like that, had 2 over 1, and then I went back to the G over
Because my point is that the function spits out G over L, but this is really the marginal utility of lures over guitar picks. So I'm thinking that you flip those. You see what I'm saying? Yes. You kind of looked at this and said, oh, that G goes with this and L goes with this, is what I'm thinking flipped you around.
Yeah, I mean, I ended up with 2 over 1, and I just looked at the problem that we did in the classes, and I just flipped them.
Okay. All right, so does that help, or does that help a little? Okay. And then again, the thing when if you start to match this back to a graph at some point, maybe on a different problem, is to go back to the rise over run business. That this is change in utility over the change in L over the change in utility over the change in G equals dollars per lure and dollars per guitar pick. And then you get the rise of the run business back to where the G's the rise, right? Because as you flip this around, the change in G over the change in L gives you the rise of the run business. That helps you match up the slope business so that you know you're measuring G here and L here, and you've got a budget line and a difference curve. Okay. Anything else on that problem? All right, we're going to have more practice because Chapter 5 also stays with these topics. So we're not out of the woods, and so if you're still a little foggy, you'll have time to get the fog out before we get too far. But I want to do 4.5 next, which I think you guys have copies of. I think. You got one more on there, right? That's yeah, the pizza chain. Okay, so that's the one we're going to do next. And this one kind of pushes us on our budget constraint and adds a little bit more reality to it. So, a pizza chain recently offered the following special promotion: buy one pizza at full price and get your next 3 for just $5 each. Assume that the full price of pizza is 10 and your daily income is 40, and the price of all other goods is $1 per unit. Draw a budget constraint for pizza and all other goods that reflect your situation both before and during the special promotion. Put the quantity of pizzas on the horizontal axis, indicate the horizontal and vertical intercepts, and the slope of the budget constraint. So go ahead and work on this. You can work with your neighbor if you got one, or kind of check your answers with the person you're next to. Maybe you might luck out. Yes, I do have one. Actually, I got another one. Everybody else got their copy? Oh wait, no, I don't have another one. So maybe that was it. So how are you guys starting this one off with this kind of different type of pricing scheme? What's your approach? Okay, so figure out all possible combinations you could afford, which is going to be weird, right? It's going to be a Our normal budget constraint has a single price. That's why our budget constraint line is the golf club, because price of pizza is $10, all other goods are $1, gives us a line. One changes, we get a straight line. This is not a straight line. So you gotta follow that pricing scheme, and so think carefully about what is possible with different levels, and then map those points out on your graphing space. It's probably a good way to go about it. Think about what's possible for you to buy, because that's what the budget constraint does, right? It shows the outer boundary of what you can afford, and that's essentially what you're mapping out. What's a great place to start with budget constraints? The intercepts. Spend all your money on one good or all your money on the other. That'll give you a great start. So what's our intercepts? If we spend it on all other goods, 40. Okay, and if we spend it all on pizza, how much? 6.
Can we do the original one first? Like without the commission?
Is that what it asked for?
Yeah.
Oh, sorry. Yes, we should do that first.
But the original one would just be 4 and 40.
Right, that one kind of back to the 4 and 40. So this is kind of our normal one. Oh, did you already work there?
Yeah, I thought
Okay.
that we had done this before.
Okay, yep. I understand. I didn't quite get there. Maybe I need to have you come up and lead lecture, Katie.
Do what?
I might have to have you come up and lead lecture. So be prepared. Be prepared to explain it to others. So think about giving up a unit for your first piece or second piece, like, okay, what if I'm here, start to work your way down, like, to get the first pizza, what does it cost me? The second pizza, under the promotion now. Is that what you're doing? So think about starting at this point, and then what is the first pizza, the second pizza, the third, and just kind of keep working out how much you're spending. Okay, it's not going to be a straight line.
Oh, it's gonna be bowed.
It's going to be different. So start from 40 and ask yourself, well, what does the next point look like? If I buy one pizza, where am I? The second pizza, the third, and following the promotional rate.
And just make points.
It's going to, yep, and just make points. Did you do that one in pen, Cody?
Yeah.
Here,
So I was
Colby?
trying to make it good.
So you're gonna, yeah, I would start thinking about the first pizza, the second pizza, and just start mapping out some points. On what?
I sent you an email last night with the paper attached to it, if you need.
I hadn't seen it this
a
morning yet.
copy. Is that okay that I emailed it, or would you prefer, I just didn't know if you had any.
I'll get back to you if I don't, otherwise I think that's all right. should start to get some points hopefully got going on here, right? So the second, the third, and the fourth are all just running us out. And we can go, just call these some points. The fifth pizza runs us right back to $10. So if you draw it really carefully, that's steeper, and then that flattens back out to the same slope. Right? Everybody get that? So I want you to start thinking about, I know you had to kind of plot it along, but we're always trying to think about the price ratio. The slope of the budget constraint is the price ratio that you face at the margin in this case. Now usually it's the single price and we just have our good old-fashioned one, but now we have this little special. So the last, once I bought my fifth pizza, I was back to the, now it costs $10, but you get the next three, but then I ran out of money, right? Okay, so what does this do for utility then? So what's our question? How is this special offer likely to alter your buying behavior? How is it likely to alter your buying behavior? Probably going to be buying more pizza, right? So they were successful probably at getting you, pushing you out. Now, from our indifference curves, where are we likely to be? What's your gut feeling tell you where maybe the likely consumer point is going to be? D. Why do you say that? I agree. Why? It's the furthest out, right? So if we start to think about that indifference map pushing out, notice that because we've made a point out here, there could be a number of different preferences that would get you to that point. Let me give you an example. So maybe let's just say our normal looks like this, and we got this nice indifference map. But if my preferences were like this, we get it. If my preferences were like this, we get it. See what I mean? Remember, the slope of the curve means different preferences. So we're actually capturing a lot of people's preferences by maxing out at this deal potentially at that point. Now, that's not everybody necessarily though. So if we have an indifference curve that looks like this, it's possible that as we push out, their indifference map pushes up like this, and their optimal point is still at point B, right? So as the indifference curve points towards the thing they love or the thing they hate, remember that little trick I tried to tell you last time? The thing they love. So it tends to point towards the thing that they love. They don't like pizza. As the indifference curve is flatter and pointing more this way, that was one of our extreme cases. And so that makes sense then that even though pizza's cheap, they're not buying a lot because they don't dig pizza. They like it once in a while, but they don't like it all the time, right? So that's part of the insight we're trying to draw from this problem.
And also, I was thinking about this, in how, like, I think I just wanted you to, like, notice that the slope is changing from -10 to -5.
Yes. Yep. And that's what I didn't write it down, but that's kind of that first part I was thinking. So we got the slope is -10 over this line segment. The slope is negative, what are we, down 5? And then we're back to 10. And all of this is following the price ratio change because of the kind of weirdness of the deal. Buy one, get the next three. Buy one, get the next three. And so that ends up giving this topsy-turvy budget line. Okay, this is one of the reasons I like to go through this example is that when we get into advanced pricing behavior of firms later, we'll talk about bundling of products and these volume discounts, and we're going to get into a bunch of pricing schemes. And so this gives us a little bit of insight from the consumer side that there's quite a few consumers that this is going to capture if their preferences are like that. Okay. So that is good for that problem. Chapter 5. I haven't decided when, but we'll have a test after chapter 5. So, because the chapter 4 and 5 kind of go together with similar thought here. And I'm going to take a look at breaking down the effects for the consumer a little bit different way. Oh, that's good. I thought I had too many here. Okay, so let's start with Annika. So Annika spends all of her income on golf and pancakes. Green fees at a local course are $10 per round. Pancakes mix is $2. When Annika's income's $100, she buys 5 boxes of pancake mix and 9 rounds of golf. When Annika's income's $120, she buys 10 boxes and 10 rounds. Based on these figures, determine whether each of the following statements is true or false. Briefly explain your reasoning. So golf is a normal good, pancakes is an inferior. Normal and inferior, what does that mean? Good. So when your income goes up, you buy more normal goods. Inferior goods, just the opposite. You buy less. So that's what we need to start off with. Go ahead and graph this out. Graph Annika's budget constraint. And that'll give us something to go on in terms of checking out her behavior with pancakes and golf clubs. Oh, good question. We can put, it doesn't matter, but yeah, let's all do it the same. Let's put green fees on the vertical axis. Not for any particular reason, but. Okay, help me out here. What is this thing looking like? What's our intercept for greens fees? 9. And what's pancake mix on the first 5? Okay.
When, just because, like, I feel like if just because of budget constraint, with her income being 100, she has the opportunity so why wouldn't that be it? You know what I mean? Like-
Okay, let me get it down on paper here first. So this is the first budget constraint, right? 9 and 5? And so income equals what, 100? Okay. And then the second one is at 10 and 9. It's 10 and 10, yeah. Okay. So what do we have? Income going up to 120. Did prices change? What's the first one? Did the prices change at all over both? I didn't think so.
See, that's what I'm saying, like,
So-
I think it should be, like, her possibility, and then these will just be a point on that budget.
So green fees are $10 per round,
Yeah.
so she could have 10.
Yeah, so that should be, for the first one should be.
So this isn't 9 though,
It should be.
right?
That's the number. I mean, that's what she wants.
I guess how much she's
Was the
choosing, is that's
$100
her
that she
bundle.
wants to spend.
That's how much she buys.
Yeah,
That's not the end point though.
that's what we're saying.
Okay, okay. So you're telling me, I was looking, I said, well, my question was, what are the intercepts?
Yeah, that's what, and I was trying to tell you earlier that
Okay.
that was wrong.
Gotcha, alright. So let's go back, start over here. What are the intercepts? So income's 100, and we can buy 10 greens fees
And then 50,
and 50 pancakes, because they're $2 a pop. Alright, now I'm probably gonna run out of room, but maybe not. Yeah, because I was trying to scale this accordingly, so on. So then if we go up to 120, what do we got?
10 and 12. Oh, so
10.
12 and 60.
12 and 60. So we got 10 and 50. Just make these a little bit smaller. And then we go up to 60. Which, if I drew it right, those are perfectly parallel. Yes. Why? Why did I know I got the wrong answer with the numbers you gave me at first? Because the prices didn't change. So the slope of the budget constraint is the price ratio, and that's why I asked, well, did income and prices change? And I had to reread the problem here. So, okay. So that is the effect of an income change. Parallel shift out. Now we put the numbers back in. So when goods are 100, when she has $100, Blake, what is she actually buying?
9 rounds of golf and then
5 boxes of candy. Okay? And when we're at 120 of income, what are we actually buying?
10 boxes of pancakes and 10 rounds of golf.
10 boxes of pancakes and 10 rounds of golf. All right, so that's our points. Kind of A and B here, if you want to call it that. Those are the actual consumption points. So part A says golf is a normal good and pancake mix is an inferior good. True or false? False. Why? She buys more pancakes. Okay? So both goods would be normal goods in this case. Now, to make the answer true, notice that we could have went to a point like C, which would be spending all of her money, reducing pancakes, but increasing golf rounds. Okay? So that would have made the answer true if we would have went to point C. Yep.
If she would have bought the same amount of pancakes, would it still be an inferior good?
No. No, just not related to, if it stays perfectly zero, they're just unrelated to income.
So they both increased when she got more income, so that's why they both were more good.
Yes.
She consumed more of both.
She
of them.
consumed more of both. Okay, so luxury goods. That was mentioned in the text. We haven't done too much of that. Does anyone remember how to define a luxury good? Something to do with the elasticity. What about it? You're right. And what kind of elasticity? So we got normal goods, we got inferior goods, and then they give this special class of luxury goods. And it does have to deal with elasticity. You guys should know the percentage way. So if we talk about the income elasticity, what is it? The percentage change in price or quantity?
Well, I know
Quantities on the bottom or top? Top. That's correct. Bottom price. No, not for the income elasticity. So it's income. Yes. So that's how we calculate the income elasticity. And the formula ends up being very similar to what we found for the price elasticity. What was that? If we use it in terms of the change in something over the change in something times the somethings.
Percentage change in Q.
And then were these reversed? Or what goes up here? I over Q. How can we double check that? Change in quantity over change in income over income. Flip the denominator, multiply times the numerator, and you get that. All right? So this is our formula for the income elasticity. Okay, well that's all fine and dandy. To make it a luxury good, it needs to be greater than 1. So the income elasticity is greater than 1 for a luxury good. I'm not going to calculate it for this problem. We're going to move on to the next one. But you can plug in, the first one's going to be false because the income elasticity is less. Yeah, so the statement's false for part B and true for part C. And all you got to do is plug in those numbers with the changes. So you got the change in income, right? We went from 100 to 120. Plug in the numbers, plug and chug at each point A, point B, and calculate the income elasticity. And you'll see that the first one is less than 1 and the next one's greater than 1, so that's true.
So when you're doing the change in quantity, are you looking at the change in like her maximum potential, basically? Or are you looking at
No,
what she
for her,
got?
remember A and B is what she actually did. Yep, so we're using those numbers. And then we're just picking off the vertical axis. So golf went from 9 to 10, and pancakes went from 5 to 10. So you have to do each one separately.
For the income on B, for the elasticity formula, which income do we use for the right side of the equation? The 120 or the 100?
You could probably, for this problem, average them. Let me see what they did here. That would be kind of the normal thing to do. I don't think it's going to matter too much. They went from the 100. So it went from, the normal formula for percentage change is new number minus the old number. So the percentage change in a variable x is equal to the new number minus the old number divided by the old number. Most of the time we're finding kind of point estimates at that, but so I guess since they did it this way, but in principles class we averaged it. You're going to get a number either way that's going to be the right answer for this problem. Okay. Anything else there?
Can we do like the full thing
No, but I'll do it after class with you. Anybody else who wants to stay after, I'll do it. Okay? And the answer's in your book.
Yeah, I know. I'm
Okay.
just kind of reading
You wanna
it,
work through it?
not making sense.
Okay. I will work through it with you separately. Flip over your sheets. I want to get to Cooper. In our time remaining. Cooper allocates his weekly budget to entertainment. He spends all of this $200 on two goods: theater tickets, which are $50 a pop, and movie tickets, which cost $10. Part A, with theater tickets on the horizontal axis, draw Cooper's budget constraint. Make sure to indicate the horizontal and vertical intercepts. What is the slope? So work on that one. And actually, I'd prefer you guys not to or not to look at the answers, because they're really, that's why I kind of set it up this way. So why don't you close your books? But that's for good review later. But I think there's little neurons that fire in different ways if you can't glance at that answer right off the bat. And feel free to move on to part B too if you want. So, what did we get for our endpoints? We spend all of our money on movie tickets. We have how many? 1A. Spend all of our money on theater tickets? 4. Okay. And then we've got a slope that you could get a couple different ways. Rise over run tells us it's 5. What's another way you could double check your work?
With each point.
Prices, what are they?
50 and 10.
50 and 10. So the budget constraint, the slope of it's always the price ratio. So negative the price of whatever you're measuring on the horizontal axis over the price of whatever you're measuring on the vertical axis. 50 over 10 gives us the 5. Okay, so we get a couple different ways to double check it. All right, so B. Suppose that Cooper currently purchases 3 theater tickets per week. Indicate the choice on the budget constraint and mark it as point A. Draw an indifference curve that is tangent to the budget constraint to point A. How many movie tickets does Cooper buy? Okay, yeah. Why did you get your answer for movie tickets?
Like, how did I get it?
Yeah.
I went to my budget constraint and plotted in 3 theater tickets and whatever.
Okay. And why is that the right thing to do?
Within his budget constraint.
Okay, and why is that the right thing to do? You're right. You haven't said anything wrong yet. I'm just trying to drill deeper and deeper and deeper. I want to know why you did that. Why does that make sense? Because his income hasn't changed. That's correct, but not. What?
Maximum utility,
And why? What about it?
because it's the difference curve is point at that point.
Yes. So, I mean, that's all correct. So,
So that she has a preference.
what are you implicitly doing by shoving 3 into the budget constraint and figuring out that this is a 5? What are you implicitly doing for, do we have a name on this person? Cooper.
Figuring out his possibility.
It's his kind of maximum possibility, right? We used his budget. We don't have a utility function to go back into, so we don't know his real preferences. So what have you implicitly done by shoving the 3 back into the budget constraint, solving for 5?
Thinking of bundle.
Yes, and what about that bundle? Yeah, what about his preferences? What did you do by solving for 5? Let's look at the equation.
Assume that he would spend all the income.
Very good. That's what I was looking for. That's what you've really assumed implicitly, that he spent all of his income. Why would he do such a thing like that? How do we know that maximizes? But why? How do we know that maximizes utility?
Well, it might not, because he might not get any utility from getting a movie ticket. Like, he might be indifferent with movie tickets.
He could have some weird preferences, yeah.
It also says in the problem, he spends all of his time.
He spends all of his money. Now, why would he have incentive to spend all his money under the assumptions of the model? Does he get any utility from leftover money? No. He only gets utility from movie tickets and theater.
So we're just assuming that movie tickets will give him some utility.
Yes.
He's not indifferent.
Yes, and we could even possibly, it would be a little different if he had weird preferences, but I just want you to really understand that according to the model, we're maxing out his budget all the time. In reality, we could tell a more sophisticated story of he lives in time period 1 and time period 2, and so he has the ability to consume stuff in time period 2, and therefore leftover money in time period 1 gives him some utility. Gets really complicated when we start to do stuff like that. But you got to know the bounds of your model, right? This is the basics. So we're creating an economic model that doesn't necessarily reflect reality, but we have to know that so that we can hopefully gain some insights about what really does go on. All right, so you picked this point, which was all correct. If he has some well-behaved normal indifference curves, then we know that there's a utility function that is tangent to that budget line right at that point. What's that?
That means that the utility in the budget constraint has the same slope at that point.
Yes, and that is our utility maximizing condition. That's the optimal condition. So the utility maximizing condition, which we wrote on the board last time, the condition that must be met is that the slope of the utility function, or the indifference curve, the slope of the indifference curve must be equal to the slope of the budget constraint. Right? That's our condition that must be met. Graphically, that's met by having the indifference curve and the budget constraint just kissing each other. Okay, questions on that? Let's see, part C. Suppose that the price of theater tickets rises to $80 and Cooper lowers his purchases of theater tickets to $2. Draw Cooper's new budget constraint and indicate his choice with a point B. And draw an indifference curve tangent to the new budget constraint. So,
Can you buy half a ticket? Like, you know what I mean? Like, how would you
Yeah.
graph that?
in reality, no, you can't buy half a ticket. So I'll talk about that later.
Who's gonna have leftover income?
If he chooses to
Right, right. Could run into that if there's either at the margin, you'd have to pick one or the other if we have to split time. And that last part's going to be a little, it's going to get tough to draw. I should have warned you to make this big. On the next thing we do, we'll have a little bit bigger one, but we'll work through it. Orange going here, so let's see. Got the 2.5, good. Okay, yep. Okay, good. All right. You guys are all on the right track. So, there's an indifference curve, so we're given in the problem that he's optimizing at 2. So that means we know that there is an indifference curve that's tangent at that point. And let's call this U2. We can't have indifference curve crossing. That's one of the things I was looking for, to make sure that you're kind of keeping your indifference curves don't get sloppy and have one kind of crossing over. So indifference curves can't cross is one of our properties. All right, so that was part C. Once again, the price of theater tickets rises to 100, and Cooper lowers his purchases of theater tickets to 1 per week. Draws new budget constraint and shows choices on the budget constraint with point C, and draw an indifference curve tangent to that. So he drops his purchases to 1, but they go up to 100. So all right, so what we're doing is starting to show how utility relates to demand, to the demand curve. And so we're looking at different prices of theater tickets and ultimately the quantities of theater tickets purchased. So your homework for Friday is just to finish this problem out, mapping out the demand curve, and draw kind of a nice little graph, and you can create the demand curve. All right.